Hello students, so today we are going to start our next topic of chemical bonding, which is covalent bond. Okay, so we'll start about covalent bond. Covalent bond. So how covalent bond takes place? We have already seen ionic bond or electrovalent bond, which forms through the transfer of electrons. But what happens in covalent bond? By sharing of electrons. Covalent bond is formed by sharing of electrons. Okay, it is more towards a friendly kind of bond. Okay, friendly kind of bond. In friendship we share our tiffin with one another. Okay, similarly in covalent bond they share electrons. Why they share electrons? We already have studied that due to the attainment of stability, bonding take place. Okay, so here by the process of sharing of electron, the atoms will get stabilized. Okay, and the covalent bond will be formed. Okay, so we will see how this covalent bonds formed between different elements. Okay, and one more point, students, that covalent bond is formed between non-metals. So what are non-metals? That accepts electrons. Simple. Electrons. In the ionic bond we already have seen that there are two elements, one gives out electron and one accepts electron. But in covalent bond both the elements will be non-metal and both will be electron acceptors. Okay, but there will be no transfer of electron in covalent bonding. There will be only sharing of electrons in covalent bonding. Okay, so if we see an example, just take the formation of HCl, which is a covalent compound. Why it is a covalent compound? Because the bonding is formed by covalent bond. Okay, by sharing of electrons. So we'll see the formation of HCl. Formation of HCl. Okay. So the electronic configuration of hydrogen has got only one electron. Okay, in its orbit. Hydrogen has got one electron in its orbit, is shown by cross mark. And chlorine in its outermost shell, the size of hydrogen will be smaller than chlorine. Okay, so when you draw, keep it in mind. Chlorine, so the size of chlorine will be larger. Okay, so what happens? Hydrogen has got one electron. So hydrogen is saying to chlorine, if you give one electron to me, I will become stable. Only one electron is needed. Okay, because if it accepts one electron, it will be converted to the electronic configuration of helium, which has two electrons in its valence shell. Okay, so hydrogen only needs one electron to complete its duplet. Okay, and chlorine has 7 electrons already in the valence state. It only needs one electron to complete its octet. Okay, so what they are having a mutual understanding among one another, that if you share your one electron, I also will share my one electron with you. Okay, and both of us will become stable. So there is a mutual understanding between them. Okay, mutual sharing. So this is a shared electron pair. Okay, this is shared by both hydrogen and both chlorine. Okay, so due to the sharing of electrons, this covalent bond is formed. Okay, We can take many examples like the formation of water. Formation of water. We use water in our day-to-day lives. So you must know how water is formed. How water is formed. Okay. So oxygen. Oxygen has got 6 electrons in the valence shell. Six electrons in the valence shell. So what it will need? It will need 2 electrons to complete its octet. Okay. So it will do by sharing of electrons. Hydrogen already has 1 electron in its valence shell. So this 1 electron will be shared with oxygen and 1 electron of oxygen will be shared with hydrogen. So there will be mutual sharing. Okay. So ultimately we will get, so how much electron has oxygen got? 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons by oxygen and hydrogen has attained 2 electrons, which is duplet. So H2O is formed like this. Okay. So this is bond. Bond is forming between hydrogen and oxygen. So this is called covalent bond. Okay. But there are 2 electron pairs which are not shared with hydrogen. Why it is not shared? Because it is not needed by hydrogen. Hydrogen only needs 1 electron to share. Right? So these are called lone pairs of electrons. Lone pairs of electrons. So oxygen has got 2 lone water molecule has got 2 lone pair of electrons. Okay. And these are called shared pair. Shared pair of electrons. Okay. So 2 lone pairs will be there. Right. Now there are different kinds of covalent bond. So what are the different kinds of covalent bond? That we'll study now. Okay. So there are like single bond that we have already understood by the formation of H2O. Only single bond, one bond is present. One bond. Single bond. There are double bonds. Double bonds is there. Example is yours. Between 2 oxygen atoms, double bond is formed. Okay. So you see the formation of oxygen O2. That is the essential thing for respiration, right? So oxygen, without oxygen we cannot live. Okay. So it's very essential to know the formation of oxygen. Okay. So we know that oxygen contains 6 electrons in its valence shell. This is another oxygen. It also has 6 electrons in its valence shell. Right? So it has 6 electrons. It has also 6 electrons. So if 2 electrons is given to this oxygen, 6 plus 2, it will become 8 electron. Its octet will be reached, right? If 2 electron is given to this oxygen, it will attain its octet. Okay. So they will share electrons with one another. So by sharing, this oxygen is getting the 2 electrons of this oxygen and this oxygen is getting the 2 electrons of this oxygen. Okay. So 2 bonds are getting formed. That's why you are calling it a double bond. Okay. There are triple bond also. Triple bond. So what are triple bonds? 3 bonds will be formed. 3 bonds will be formed between the two elements. The famous example is nitrogen. Nitrogen is a famous example. Formation of N2. Formation of N2. Right? So, the nitrogen has got 5 electrons in its valence shell. 1, 2, 3, 4, 5. Okay, it has got 5 electrons in its valence shell. So already it has 5 electrons, so it needs extra 3 electrons to complete its octet. Okay. Similarly, this nitrogen will also need extra 3 electrons to complete the octet. Okay. So what they will do? They will share electrons with one another. So to get 3 electrons, it need to form 3 bonds with the other nitrogen. Okay, so 3 bonds will be formed between 2 nitrogen atoms. Okay, so that is called triple bond. Okay, now covalent bonds can be classified according to polarity. Okay, so what is polarity? Okay, or you can say polarity is attained due to formation of dipole. Okay, dipole means two poles are formed. One is positive, one is negative. So how these two means charge separation will be there, simple. So why charge separation will occur? Because when there will be electronegativity difference between the two atoms forming covalent bond, there will be charge separation. Okay, as we have seen in the example of HCl. Okay, so suppose the bond pair, they have shared their electrons with one another. So this is the shared pair of electrons. Okay, so chlorine is more electronegative. Than hydrogen. Okay, so chlorine is more electronegative than hydrogen. So what it will do? It will tell hydrogen that because I am more electronegative, I should get more benefit. No, because a more electronegative atom will attract the electron pair towards itself. Okay, so the electron pair will be more towards chlorine. Okay, and it will be away from hydrogen. Okay, it cannot completely take the electron pair towards itself. As we have seen in the ionic bond, complete transfer was taking place. Okay, from one atom to another atom. Okay, but here the complete transfer will not occur. Only there will be slight shifting of electrons towards the more electronegative atom. Okay, so we can say because this electron pair is shifted towards chlorine, so chlorine will have slight negative charge and hydrogen will have slight positive charge. Okay, so that is given by delta. Delta signifies it is very slight, very small charge. Okay, so chlorine will have delta minus charge and oxygen will have delta plus charge. So these are the two poles. These are the two poles of a dipole, right? And because of this charge separation, polarity is existent in polar covalent bonds. Okay. Now we'll understand what are non-polar covalent bonds. So how non-polar covalent bonds can be formed? Second is non-polar covalent bond. Okay, simple. You can think by yourself and you can give me the answer. Okay, the first one is when bonding takes place between the same kind of atoms. When bonding takes place between same kind of atoms. We already seen, no? Between two oxygen atoms. Suppose two hydrogen atoms. Okay. The electron pair will stay in the middle because both are same atoms. The electronegativity difference will be 0. Okay. Both are having same electronegativities. Okay. So the electron pair will stay in the middle and there will be no charge separation. And if there is no charge separation, no polarity will be developed. And this comes under the category of non-polar covalent bond or non-polar covalent molecules. Okay. And the second one is, if we see the formation of carbon dioxide. If we see the formation of carbon dioxide, just write carbon here. Carbon has got 4 electrons in its outermost shell and oxygen has got 6 electrons in its outermost shell. Oxygen has got 6 electrons in the outermost shell. Okay. So you can do it by yourself only, that oxygen has got 6 electrons. It needs 2 more electrons to complete its octet. Okay. And carbon has 4 electrons in the valence shell. So it needs 4 more electrons to complete the octet. Okay. So what it will do, it will share 1 electron with 2 electrons with this oxygen, and this carbon will share 2 electrons with this oxygen. When they are sharing, so how much electrons will carbon have? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So it has completed its octet by sharing of electrons with oxygen. And oxygen is also completing its octet by sharing 2 electrons with carbon. Okay. So if we write the structure of CO2, it's like this. Linear structure. It's like a scale. You can think of a scale. Okay. It's a linear, it's like a line. Linear structure. Okay. So since oxygen is more electronegative, so there will be delta negative. Delta negative will be there, right? And above carbon there will be delta positive. Okay. So electron will shift in this direction. This is a sign of dipole moment. Electron will shift in this direction. Okay. So the opposite dipoles will cancel each other. Opposite dipoles cancels each other. Okay, the opposite dipoles cancel each other because same amount of force is applied in both direction, in opposite direction. So it will cancel each other. So the net polarity will be 0. Polarity equals to 0. Okay. So there are 2 types of conditions for non-polar covalent bond. When the atoms will be same, right? When the atoms are same, there is no electronegativity difference, and for that there will be no polarity. Okay. And when the opposite dipoles cancel each other, there will be the polarity will be 0. So it is also a non-polar compound. Another example of non-polar compound is CCl4. Okay. So its dipoles will also get cancel each other because of the opposing nature of the dipoles. Okay, so it is also a non-polar compound, right? Okay. Now there is another concept, okay, that is like dissolves like dissolves like. Okay, so what it is all about? Okay, so polar compound will be soluble in polar compound, right? We already gave the example of NaCl. When you mix this salt with water, why it is getting mixed? This is also a question, right? There must be a reason behind it. Okay, so what is the reason behind this mixing of NaCl and water? Because water, if we already have seen the structure of water like this. Okay, so it is also a polar compound. Delta negative, positive, positive. Okay, so it will have a dipole moment, and because of that, and you can say that why the dipole moments are not cancelling each other? Because they are not opposite. They are in the same direction. They are not opposing to each other. They are in the same direction. So here the polarity, there will be some polarity in the molecule. Okay. So because of the polarity, NaCl is already polar because of positive and negative charge. Okay. So the like will dissolve like, right? So when NaCl is given to water, it gets completely dissolved. It gets completely mixed with water. Okay. Because like dissolves like. But if you give CCl4 is a molecule, same chemical compound. Okay. So which is non-polar. Right now we have seen that it is non-polar. Will it be soluble in water? No, it will not be soluble in water because it is non-polar, but water is polar. So the polar molecule cannot make the non-polar molecule soluble. Okay, so CCl4 needs some non-polar medium. To make it soluble. Okay, so it is soluble in oils like organic compounds. It is soluble in benzene, which is very oily. If you touch benzene, it is like an oily substance. Okay, it is also non-polar. So CCl4 will be soluble in benzene, but it will not be soluble in water because of its non-polar nature, right? Now we'll see what is coordinate bonding. This is the third type of bonding that occurs between the elements. Coordinate bonding. Okay. This also occurs by sharing of electrons. Sharing plus transfer. Not transfer. Sharing plus partial transfer, you can say. Partial transfer of electrons. So coordinate bonding occurs by sharing and partial transfer of electrons. We have already seen during the formation of H2O that there are two lone pairs of electrons. So what are lone pair of electrons? The electrons which does not participate in bonding. Okay. And what are bond pair of electrons? The electron pair that participates in the bonding. Okay. So lone pair of electrons are those electrons which participates in the bonding. Okay. So in water, oxygen has already completed its octet. Okay. So it has already completed its octet and it has got two lone pairs, right? So in coordinate bonding, two parameters, like two species are needed. One is donor and one is acceptor. Okay. So a question can come in your mind that in ionic bond also we have seen donor acceptor. The metal is donating electrons and the non-metal is accepting electrons. So what is the difference between coordinate bonding and ionic bonding, right? In ionic bonding we have seen, just let us consider the example of NaCl, okay, where Na had incomplete octet, and Cl also had incomplete octet. Okay. But what is the difference with coordinate bonding? Coordinate bonding, the donor will have complete octet and the acceptor will have incomplete octet. Okay, so this can be compared with sacrificial love. Okay, the donor is sacrificing for the acceptor. Okay, donor has already completed its octet and it's already stable. So why should it give its electron to the acceptor? Acceptor is asking donor that you are already stable. He's asking his friend that you are already stable. Like, give me some stability that you have attained so that I can also be stable. But donor is also like, he is also wise, right? Because he does not want to lose its stability, but it also wants to help the acceptor. Okay, so it is sacrificing its lone pair to give it to the acceptor, but itself it's also stable, right? So we have seen water, it has lone pair of electrons which is of no use to this molecule. Is situated in the above the oxygen only. So it can donate its lone pair to some species which needs electron. For example, H plus ion. We have seen the electronic configuration of hydrogen is, it has got only one electron in the valence shell. So when it loses this one electrons, it is converted to H plus. Okay, so in H plus no electrons is there. Okay, so H plus is completely vacant. Okay, so if this oxygen decides this H plus is completely vacant, so let me give some electrons to him so that he also can be stable. Okay, so this H plus is sharing, this oxygen is sharing the two electrons with H plus. Okay, so both of them are sharing these two electrons with each other, right? So when oxygen is sharing these two electrons with H plus, it is helping H plus to become stable. Okay, so this type of bonding is called coordinate bonding. So let us again refresh our memory that coordinate bonding needs two species, one is donor and acceptor. So donor will have complete octet and the acceptor will have incomplete octet, and the electron will be donated from the donor to the acceptor. Okay, so the finally what will form? H2O plus H, H3O plus, H3O plus will be formed. Okay, so another type of compound we'll see, another type of ion we'll see where coordinate bond is taking place. That is formation of ammonium ion, formation of ammonium ion, which is NH4 plus. Okay, we have not seen the structure of formation of NH3, how NH3 is formed. We can see it here. first we will see the formation of NH3. Okay, so N has got 5 electrons in its valence shell, 4, 5. Okay, so it needs another 3 electrons to get stabilized, right? So 3 hydrogen atom can share it 3 electrons with the nitrogen, right? So when 3 hydrogen atoms sharing its 1 electron with this nitrogen will have 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. And hydrogen is attaining duplet electronic configuration. And this is attaining octet. So both of them are getting stabilized. This is an example of covalent bond, but this electron pair is not participating. So this is lone pair of electrons, which is not participating in bonding. Okay. So we can simplify the structure like this. It has only one lone pair of electrons. Okay. I already discussed that H plus has no electron. No electron. It is completely deficient of electrons, right? But NH3, this is the donor. Filled octet. Excuse me. Filled octet, right? So donor will have filled octet. But the acceptor has no electron. Acceptor has no electron. So this donor will give out H2 electron to H plus. And this type of bonding is known as coordinate bonding. But this is not complete transfer. You cannot think it to be completely transferred to hydrogen, because this is not completely transferred. It is already also shared by this. If it is completely transferred to hydrogen, then nitrogen will be devoid of 2 electrons and its octet will be destroyed. That can't be possible, right? So it will not completely transfer its electrons to hydrogen. It will share its electron with hydrogen. Okay. So by coordinate bond we are also attaining stability, where the donor is already filled, already having octet configuration, but the acceptor is not having octet configuration, and the donor is helping the acceptor to attain the octet configuration without losing its stability, right? Now we'll see a compound which has got all the types of bonding: ionic bonding, covalent bonding and coordinate bonding. That is NH4Cl. So if someone asks you, give me an example of a compound which contains all kinds of bonding. Okay. So we have 2 types of ion, NH4 plus, Cl minus. So there will be ionic bond between them, right? Now, how NH4 plus is formed? NH3 plus H plus. This is coordinate bond. And now how NH3 is formed? By covalent bonding. So all the 3 kinds of bonding are present in this molecule, right? So you can give an example of this molecule which contains all the 3 types of bonding. So students, our chemical bonding chapter is completed here. So if you have any difficulty in understanding, or if you have any doubts, you can post in our comment section, and also you can mail us. We will get back to you with your doubts. All the best for your studies. Keep on studying. Thank you.